Hello there, this video continues my sub-series on exotic options. You'll recall exotic options is a catch-all category because they are defined as any options that are not standard or vanilla. I say it's a sub-series because they're in their own playlist, and the broader sequence is Part 1, Topic 3 of the FRM. That Topic 3 is called Financial Products and Markets. So that's the broader sequence. But within this sub-series for exotics, this playlist, I've already recorded 3 videos, compound on, respectively, compound, barrier, and chooser options. And this video then gets me to binary options, which are also called digital options. And you'll see I'll have 4 more to go after that. And so I will explain the mechanics of a binary, aka digital option, and then at the end, I'll show the intuition, how we can use the intuition of these digital options to actually understand how we price or value them. So first, I'd just like to remind you of the payoff plot for a long call option illustrated here, right? So this is a payoff plot, we call that, where this long call has a strike or exercise price equal to $10. We wouldn't need the label because we know that necessarily it inflects at the strike price here of $10. This x-axis is the future stock price, the stock price at maturity or expiration of the option. Further, we know it's a payoff plot because here, where the option expires with 0 intrinsic value or out of the money, there is a 0 payoff, and that's exactly where this line falls. If we subtract the cost, after all, purchasing this option would not be free, then we get the profit. And if this were a profit plot instead, this line would be below the 0 value. But it's here, so it's a payoff plot, and we'll use this long call in just a minute. But let's look at the payoff plots, the corresponding payoff plots for a binary or digital option. And there's 2 different types. The asset or nothing is plotted in blue, and the blue is actually underneath the green here, but notice it's discontinuous. So this is an asset or nothing, which is a type of binary or digital, aka digital option, with a strike price of $10. So it has the same payoff plot if the future stock price at expiration is below the strike price or out of the money. It also has a payoff of 0. But then if the future stock price is above the exercise price, notice that it's discontinuous, and this digital option then pays the value of the asset. So if the future stock price, get rid of that, is 15, for example, then the value of this option payoff is the same 15. So this is a 45-degree angle going up. If these are exactly scaled, which are not quite exactly scaled the same. So that's the asset or nothing. The cash or nothing is also a binary or digital option, but it has an additional parameter. It has a strike price, but it also has a cash payoff value. I'm following John Hull, so we denote that Q. I happen to here, in this example, set it equal to K, but it doesn't need to set equal to K. But if my Q is equal to 10, then my cash or nothing is also discontinuous. And in this case, with the cash or nothing, if the future stock price is above the strike price, the payoff is the cash value of $10. Hence the flat line. So it's discontinuous at the strike, and then the payoff is a flat line. But as mentioned, my Q does not equal to K. I can keep my strike price at $10, but set the cash payoff to 15. So here, still discontinuous at the strike, but now my payoff is $15, or I could go down to $7. So now I bring back the call, and we notice that we can start to understand the binary or digital options as a synthesis or package of other options. So specifically, if we take a look at the short call and the asset or nothing in blue, and notice we can view the cash or nothing as having an equivalent payoff to a package that consists of the asset or nothing plus the short call. Because you can see the asset or nothing going up here cancels by the payoff of the short call, the negative payoff, and we would end up with the cash or nothing. So the cash or nothing, the value of the cash or nothing ought to be equal exactly to a package consisting of an asset or nothing plus a short call if the cash or nothing has a strike price equal to its cash payoff. So I bring back that long call, and now we're in a good position to understand the value of both of these digital options, the cash or nothing and the asset or nothing. But I need to introduce some of those assumptions that are typical of the Black-Scholes-Merton, and I'm using I'm employing underneath here in the spreadsheet, which you can download, the Black-Scholes-Merton option pricing model. So I've got my stock price today at $10, strike price of $10 for both of the digital options, and then I'm assuming the cash payoff on the cash or nothing is also equal to $10. 1 year term, these can all be changed, volatility 30%, risk-free rate of 3%, and then my model can accommodate a dividend yield, but to keep it simple, I'm assuming zero dividend yield. So in other words, these are digital options on, all right, let me just be more specific. These are European digital options on a non-dividend paying stock, is the way Hull would say that. And so the key insight here is represented visually by the fact that my asset or nothing, which is in blue and really underneath the other two, but it includes all of this here as the asset or nothing, you can see visually, I hope, that the payoff of the asset or nothing is exactly equal to the payoff of the long call in red plus the payoff of the cash or nothing. I should say conditional on K equal to Q. And that relationship mathematically is illustrated right here with these actual values. You'll notice the value of my European vanilla call option, which has a payoff illustrated in red, plus the value of the cash or nothing, which is in green, is in fact equal to the value of the asset or nothing, and the value of the asset or nothing having the highest value of all three of these. So the cash or nothing has actually the most intuitive valuation of, I think, all of the exotics. After all, this cash or nothing pays Q at expiration if the stock is above the strike. And the probability of that is actually given by N of D2, the same N of D2 that's in Black-Scholes-Merton. That's the standard normal cumulative distribution function of D2. And that N of D2 represents the probability the call option will be exercised in a risk-neutral world. If it's not, the value of this is zero. So then hopefully you can see this multiplying Q by this actually gives us the expected future payoff of this option. It's such that we only need to discount it to the present value, and we end up here with the value of the cash or nothing. Very elegant. Probability of the call option being exercised multiplied by the payoff, discounted to the present. Now, if we come back to for the asset or nothing, that we can also deduce fairly easily, because we know if we go back to the Black-Scholes-Merton, we know the Black-Scholes-Merton is equal to the stock price discounted by the dividend, reduced by the dividend, multiplied by N of D1, minus the strike price discounted at the risk-free rate, multiplied by N of D2. So that's my Black-Scholes-Merton formula that gives me the call option here. And if I add the cash or nothing, right, but conditional on, recall I said if Q equals K, then I can now add my cash or nothing substituting the K for the Q. And what I'm adding here is that same term. So here's my Black-Scholes plus my cash or nothing. These two terms cancel, and I end up here with the value of the asset or nothing, right? Very clean. And in fact, this the stock price multiplied by N of D1 is the expected stock price at the future time t in a risk neutral world when the stock price is less than the strike price. So this also directly has an intuition, but I thought I'd access it this way. And then if you're wondering why we don't further do the discounting of the present value, well, as we've seen before, the present value of a stock price in the future is the stock price today. So this is already discounted the present value. We don't need to redundantly discount it. And so that's the asset or nothing. That's the cash or nothing. And that's basically the valuation of the binary, also called digital options. If you thought this video was helpful, please subscribe to the channel and we'll keep you updated of future videos. Thank you.